Okay, question number 6. The volume of the sphere bubble increases at a constant rate of 5 cubic centimeter per second. The initial volume of the bubble can be assumed to be 0. Find the rate in centimeter per second at which the radius bubble is increasing when the volume of bubble is 20 cubic centimeter. To solve this problem, you need to know some equation, know a formula that calculate the volume of sphere. For those who don't memorize this formula, I need to show you that you can find this an official formula booklet on the page number 6 here. Volume of sphere is V equals 4 over 3 pi r cube. So you can simply start with V can be calculated by 4 over 3 pi r cubed. So in the question it says volume of sphere. So let's say this is sphere with it has some radius in here is increasing, and then those when radius increasing, of course the volume will be also increasing, right? So this volume increase, so this volume increase rate is dv over dt is given at a constant rate of 5 cubic centimeter per square per second. So 5 cubic centimeter per square is already given that. And then initial volume can be 0, and find the rate in centimeter at which radius of bubble is increasing when volume of bubble is 20. When V is 20, so we can use this formula over here. When V is 20, we can find the volume, right? So when V is 20 equals 4 over 3 pi r cubed. So we can use GDC, calculate r cube equal 5, so it's going to be 15 over pi. So r equal, let me see, GDC, clear everything. So we need to find 15 divided by pi. This number is cubic root, so times 1 over third power. So this is gonna be r, so 1.6839. So let's store this as alpha radius, large r. Okay, and then we need to find the dv dr dt. So we start from here. So V equals 4 over 3 pi r cubed. So to find dr dt, we need to differentiate both sides with respect to t. So left hand side becomes dv over dt equals 4 pi over 3 is pretty much constant. Just leave it there. R cube cannot be differentiated with respect to t, so we can apply the chain rule. We differentiate r cube first by dr with respect to r, which becomes 3r squared times dr dt. Okay, 3 cancels out, and then we put every information we got here. So dv dt is given by 5. It's given this is 5 equals 4 pi. When we put the large r, yeah, r 1.6839. So we put large r squared from the calculator, and then dr. So because we have to show our progress, we have to use 1.6839. This one is squared times dr dt. So therefore dr dt, question, v equals what? V equals 20. 20 equals 5 over 4 pi 1.6839 everything squared equals 5 over 4 pi times 1. No, we don't have to do this. We already have r, so large r squared. Yeah. So the answer is gonna be 1. What am I doing? 0.140. This is gonna be answer. The unit will be centimeter per second.